From AccuWeather.com, this is AccuWeather Daily, a brief host-read article. It's weather news in a nutshell. Super Typhoon Ragasa roared through the northern Philippines yesterday as the most powerful storm on Earth this year. It struck with destructive winds and torrential rain, prompting evacuations of thousands of people and preparations in nearby Hong Kong, Taiwan, and mainland China. Climate scientists worry that this is just a precursor, and it will continue to happen more often in the coming years. The Western Pacific is the most active tropical basin on Earth, and September is often its busiest stretch. Ragasa is a reminder of how quickly storms in this region can ramp up and how destructive they can be as they approach densely populated coastlines. Global ocean temperatures have been at record levels for each of the last 8 years. Hotter oceans, supercharged by human-caused global warming, provide ample energy for storms to strengthen. The hot ocean waters around Japan contributed to that country's hottest summer on record, which featured its all-time national maximum temperature record of 107.2 degrees set back on August 5th. On the other side of the Pacific, the ocean heat is also yielding higher humidity in Northern California at the start of meteorological fall, and if it persists, it could enhance rain and mountain snowfall from wintertime atmospheric rivers. The sea surface temperature difference from average across the entire North Pacific smashed an all-time record for the month of August, with reliable data stretching back to the late 19th century. What worries scientists is the repetitive nature of these events. As climate change causes more heat to be stored in the oceans, ocean temperatures are reaching new heights that could lead to more significant impacts from these heat waves. According to Michael McFadden, a senior scientist at the National Oceanic and Atmospheric Administration, the North Pacific warmed at the fastest rate of any ocean basin on Earth during the past decade. And the entire North Pacific Ocean basin is involved in the current marine heat wave, standing out starkly on weather maps. This event is unique for its intensity and extraordinary geographic reach, and for its potential to eventually alter large-scale weather patterns if it continues. Daniel Swain, a climate scientist at UCLA, said if the broad ocean basin-wide heat wave persists, it could influence the wintertime storm track associated with the jet stream. In parts of the North Pacific, from the Gulf of Alaska south to the coast of California, this heat wave is known as a blob of unusually hot water. It is part of a pattern of marine heat waves in this area following a severe heating event in 2013 that lasted until 2016. That heat wave remains the most severe on record. The term blob refers to how the area of warm water looks on maps showing how different sea surface temperatures are from average. This year it may be something of a misnomer, since the marine heat wave is so huge that it spans the Pacific. It also originated in the Western Pacific and gradually extended eastward. Past Northeast Pacific Ocean blobs led to a historic die-off of seabirds in coastal Alaska and affected fish species along with sea lions and other creatures that call this region home. The seabird population has not recovered, and impacts from the ongoing event have been observed on other species. Heather Renner, supervisory wildlife biologist at the Alaska Maritime National Wildlife Refuge, says longer-lasting, strong blob events tend to have greater effects on wildlife, and the ongoing one has not been present nearly as long as some past occurrences. The current event ranks as the fourth largest Northeast Pacific blob yet observed. Once strong winds from late fall and early winter storms track across the region, they will likely be able to stir up cooler water from below the ocean surface, putting an end to this particular blob. According to scientists, the cause of the ongoing marine heat wave, both the blob in the Northeast Pacific and the more enduring anomalies stretching westward to Japan, are the result of persistent anomalous wind conditions associated with stagnant high and low pressure areas. These can influence how much cooler ocean waters rise from deeper depths, a process called upwelling. This year, Winds have been weaker than normal across the basin or blown in directions that discourage upwelling. When upwelling is curtailed by winds or other factors, surface water temperatures can soar. In recent years, this has become more common in this region during the spring and summer months, usually ending in the fall. McFadden said that multiple studies have been published that attribute an increase in marine heat waves and accelerated warming in the North Pacific Ocean to global warming pollution from burning fossil fuels. The fingerprint of climate change is clearly evident in what is transpiring now in the North Pacific. McFadden said, "The North Pacific has a fever, but the story doesn't end there. The downstream effects of these marine heat waves is likely to be significant in terms of how they impact marine organisms, ecosystem structure, fisheries, and the weather in the Pacific Northwest." That's all for now. You can find more regional forecasts and science-based articles at AccuWeather.com. And for your local forecast at your fingertips, download the AccuWeather app. Enjoy the rest of your day. Be safe. I'll be back tomorrow with more from AccuWeather.